In this example, I'm going to show you how to do a simple assignment problem to give you the idea of how it works in Microsoft Excel using Solver. This is a linear programming problem where you have different routes to which you need to staff, you need to assign certain drivers. And each of these drivers have placed bids on the routes, indicating how much they need to be paid in order to run each of these routes. There's a couple constraints. One is, this is for like a busing system for a school district, so the issue here is that each driver can only be assigned to one route because each route is going to be running, all the routes run all at the same time of day, picking up students for school. So you can't have a driver in the two places at the same time. The other thing is each route must have exactly one driver assigned to it. I mean, it wouldn't make sense to have two drivers assigned to a route, right? You have a bus and you want to fill up the bus, so and use just one driver. So those are the two constraints on the situation. So we lay out what the costs are, and then you can ignore this green in here. We'll explain that later. But these are all the costs associated with each driver driving each route, indicated by what their bids are on each route. Then what happens is you have in here your decision variables. You've got that same layout of the drivers along this column and the routes along this column. And then in here there's going to be placed zeros and ones by Solver, indicating whether or not a driver is assigned to a route. If there's a 1, then that means, so in this case driver 1 would be assigned to route 2 if there was a 1 there. If there was a 1 here, this would mean driver 2 would be assigned to route 1. That's not the optimal solution, but that just shows you how this would be laid out. The other cells will all have zeros, indicating that no drivers are assigned, that driver is not assigned to that route. Okay, so that's the decision variable section of the problem. Then you have to get the constraints. So in this case, the number of routes to which each driver is assigned, what this is just a sum. If I go like this, sum D12 to E12, D12 to E12, all I did was sum up this row and put the value there. That must be less than or equal to 1. Less than meaning that you don't have to assign a driver to a route if the cost isn't enough to minimize the whole thing. This row is the same. It's this sum is what the formula is in this cell. This cell here is the sum of this row, and all these must be less than or equal to 1. The other constraint is articulated by taking the sum of this column and making it exactly equal to 1, the sum of this column and making it exactly equal to 1 as well. And so this is just another sum formula for everything in this column. The total cost is a sum product, and I'll show that. Sum product D5 to D7, so basically all this multiplied by the assignments in this section, and that will give you the sum of all of those products, which would indicate the total cost of each individual route. Okay, so to make this happen in Solver, what we need to do is we need to go to Data, we need to go to Solver, and what we want to do is we want to set the objective to this cell D19, setting it to not the max but the minimum by changing these decision variable cells subject to these constraints. The first set of constraints, and you can, instead of doing each of these constraints individually, you can just highlight this column and say that it must be less than or equal to the values on the right hand side of each equation. It knows to match up each cell with the constraint on the same row. So, and we make sure it's less than or equal to, and it is, so we click on OK. And then we want to add the other constraint. We want to make sure that everything in this row is equal to, so make sure you don't forget to change that to exactly equal to what's down here, to 1, and we click on OK. Okay, make sure that any unconstrained variables are non-negative, and then click the simplex linear programming method from the 3 options here, and then click on Solve. And then what it did was it found the optimal solution, so we click on OK. So you can see the optimal solution is to assign driver 1 to route 1, which makes sense because in the route 1 column, $60 is the cheapest price. So that will help minimize the objective function. Then driver 2 will be assigned to route 2, even though $70, which is driver 2's fee for driving route 2, is not the cheapest. You can't use driver 1 because of this constraint here that a driver can only be assigned to one route. So because driver 1 is assigned to route 1 at $60, he can't also be assigned to route 2. So that means we go to the next cheapest driver, which is driver 2. So that gives us the plan. Driver 3, you can see there's zeros down here in the decision variables. The driver 3 is charging too much, $80 and $82 for each of those routes. So there can't be any they can't be any assignments of driver 3 because driver 3 has priced themselves out of the market. Okay, so the total cost minimized is $130. The $60 for driver 1 and the $70 for driver 2 added together gives you $130. So the next thing we need to do is, consistent with what you do in the homework, is you need to come up with the cheapest bid, the driver, and the cost. So if you can just look at this and see, you can see that the cheapest bid for route 1 was $60. The driver assigned was driver 1 based on what we just established here in the decision variables, and the cost of that driver is also $60. The cheapest bid for route 2 is $65. By looking in the route 2 column, you can see the cheapest is $65, but we assigned driver 2 at a cost of $70, and that's just the way the homework requires you to lay this out. Okay, the last thing I need to comment on is the conditional formatting. The way this works here is, I'm just going to select that and go to Home and go to Conditional Formatting and go to Manage Rules. Essentially what this says is, if the formula in D1 is a 1, meaning that it was selected, highlight it in red. So if a driver was assigned to that route, then highlight the fee in this table here in red. So you can see that that will change if I went back to here. If I change this to a 1, you see if I had assigned driver 2 to drive to route 1, then 75 would be selected as red because it's a 1. So that's what the conditional formatting is doing. I'm going to put it back the way it was. And then the other thing you have to look at is go to Conditional Formatting, Manage Rules. This is an AND formula, which is essentially an if structure with two conditions. It's a simpler way of formulating an if structure with two conditions. If D12, this right here, is equal to 0, meaning that the driver was not selected, and the value in this column right here is the smallest, then put that corresponding value in green. Now you can't really see that in action here, but this formula, because it's applied to this entire D5 to E7 area, it knows to move this condition around for each cell. So we're going to explain what would happen in this column here. What it says here, if D12 is 0, and it is, and D5, this cell, is the minimum of the column, then put it in green. That's so that you can then lay out what the cheapest bid is compared to the actual cost. Okay, so in this case both of these are true, that the cell here that corresponds to this position in the driver bids is 0, and it's also smaller than the actual any other column and any other value in that cell, so it gets the green highlight. Okay, so that's conditional formatting, and that's how you do this assignment problem.